Let's learn about combustion reactions. In a combustion reaction, you always begin with a fuel and an oxidizer, and you also end up with the same kinds of products at the end. What we usually mean by fuel in a combustion reaction is a molecule that contains both carbon and hydrogen. A common example is methane. Methane is the primary component in natural gas. That's what powers your oven or stove when you see those blue flames. Octane is another common fuel that you're probably familiar with. It's the primary component in gasoline. Now, what we mean by oxidizer is any element that rapidly grabs electrons away from the fuel. The oxidizer that we're most familiar with is oxygen, which makes up a significant component of the atmosphere. So very often, combustion reactions are characterized by the reaction between a carbon and hydrogen-containing fuel and oxygen gas. Although that's not always the case. The fuel can contain elements other than carbon and hydrogen. Hydrogen alone does act as a fuel that can power combustion. Hydrazine is another example of a fuel that contains no carbon, but it's used commonly as rocket fuel. Similarly, the oxidizer does not need to be oxygen. You can perform combustion with chlorine or fluorine gas as an oxidizer as well. But most of the time in a combustion reaction, the fuel contains carbon and hydrogen, and the oxidizer is usually oxygen gas. So let's head into the lab and observe a combustion reaction. I'm going to demonstrate for you a combustion reaction. In this reaction, I'm going to react isopropanol, also known as rubbing alcohol, with the oxygen in the air. I'm going to initiate this reaction with a lit match, just a small amount of heat. To accomplish this, I have this large glass carboy, which I have just squirted a small amount of isopropanol into, and I've capped it, and I've let the isopropanol vaporize, and so there is now a large amount of isopropanol vapor in this carboy, and it's also excluded a lot of the oxygen. What products do you think will result from this reaction between isopropanol and oxygen? Remember, this is a combustion reaction. Okay, so I'm going to light my match on a yardstick, get that cap off, let's see what happens. You can see why sometimes this is called the jet engine reaction. So we saw that there was a blue flame. I'll say something pretty interesting about that blue flame in just a moment. But other than the flame, what products were created in this reaction? Can't really see anything in here, but there were really two products that were created in this reaction. One of them is actually left inside the carboy. So if I upend the carboy, there's actually quite a lot of a liquid in there. And this liquid is water. Now, if you look at the reactants of the reaction, you might recognize, well, what happened to all that carbon? Well, the carbon atoms showed up in a gas, and that gas was carbon dioxide. Now, you might have noticed in this particular reaction that there was a beautiful blue flame that dropped down to the bottom as the combustion was taking place. Why didn't all of that fuel just combust all at once? In that case, I probably wouldn't be standing here talking to you right now. The reason for that is unique to this reaction. Remember that I filled the carboy with vapor. I filled it with fuel. There was no oxygen in the carboy. So I excluded the oxygen. The only oxygen that was available to this reaction was up here in the atmosphere. The fire started only at the mouth of the bottle, and it worked its way down. So the fire was consuming fuel from below and sucking in oxygen from the neck, while at the same time ejecting carbon dioxide gas. That resulted in that kind of humming, whooshing sound that you heard, was this rapid exchange of gases in this narrow neck. That blue, beautiful interface, that flame that slowly sank to the bottom, was the location where the fuel from the isopropanol was meeting the oxygen gas from the atmosphere. So there's a pretty dramatic example of a combustion reaction. So in the lab, we saw that combustion reaction resulted in the emission of light and heat. That is characteristic of combustion reactions. They're highly exothermic, so they generate a lot of heat and a lot of light. But let's look at the products that we get in a combustion reaction. So to help us understand what's going on with the atoms and molecules in a combustion reaction, I've built our reactants using a molecular modeling kit. Over here, I've built a fuel. This is propane. This is the same stuff that runs your grill. And over here is oxygen gas, O2. That's our oxidizer. Now, what I'm going to show you here is how the bonds in these molecules all rearrange to form new products at the end. In order to do that, we need a bit more oxygen. So I'm going to add some more oxygen molecules. All right, now I have enough oxygen. I've got my fuel, I've got my oxidizer. Let's see what the products of this combustion reaction are. So now we've built our products. I just rearranged the fuel and the oxidizer so that the bonds between the atoms all kind of swapped places. We end up with carbon dioxide and water as products. Now in the reaction that I just did in the lab, I was able to actually tip the carboy up, and you could see all that water draining out of the carboy. That was this product, the water. And we could also hear the carbon dioxide shooting out of the vessel. So here's really common products of a combustion reaction: carbon dioxide and water. So that's a great example of a combustion reaction.